Thank you everyone for coming along today's webinar. Today's webinar is going to be a bit about Solid Edge, and I guess I titled it Back to Basics because we've got quite a few users who are either new to Solid Edge or who have just been starting to get the designs under road, and I wanted to show you some of the tips and tricks that I've found as I've been picking up the software myself. So I'm just going to get started. So just closing one or two other things. So this little webinar that I'm showing you today is part of a demonstration that we use for customers, and it gives them a bit of an overview of the capabilities of Solid Edge, and we call this our first look demo. This is an example of a product, a customer of ours who uses Solid Edge to design these little e-trucks. Today's demonstration will be looking at a clamp arm and how that is designed within Solid Edge. This particular arm here inside the little video you can see. So we're going to be walking through part design, part drawing, and assembly design. In a follow-up webinar, the plan is to look at an assembly drawing and how that can also benefit designers like yourselves in simulation and data management. Okay, before as I said, this is the part we're looking at designing, and what I have asked people to do is to save the questions till the end and submit them via the chat window. I've got my colleague Edmund looking at this, and if you have any questions regarding how to place a chat, he'll keep an eye out for you and help you out if you have any questions. Brilliant. So part design. Just to give you a bit of an overview of the history of Solid Edge and where we've got to. So historically, there was a lot of CAD systems that used history-based modeling. So that was where it was a dimension-driven system, highly automated, and often revolved around the feature base. So that was some really, really good features of previous CAD systems. Some of the things that weren't so good was it required a lot of pre-planning, it was inflexible, and it scales poorly on many featured parts. It often meant that your system would slow down after a while. So on the other side of the fence, there was direct modeling. This had flexible editing. It scaled well on many featured parts, and it often required direct interaction with the model, almost like what you would envisage, kind of like a sculptor would do. But again, there was some drawbacks to this. It was featureless. It was weak dimension-driven editing, so it wasn't very good for kind of precision engineering, and it had little design automation. What Solid Edge has done is they brought their own technology in, and they called it synchronous technology. It took the best of both of these modeling types, so the dimension-driven, highly automated, feature-based, flexible editing, the many featured parts scaling, as well as direct interaction, and you ended up with this system that allowed you to have procedural features, 3D-driven dimensions, and 3D face relationships, as well as design intent. So I'll refer to this feature within Solid Edge. It is a bit of a controversial one. Some people don't like it, but one of the things I hope to show you today is how you can leverage it to speed up your design process. So, part design. The first things we're going to be looking at is, as I said, the best of both worlds. It's using a robust Siemens Parasolid engine and the synchronous technology. I'll go back one. So, we'll pop over to Solid Edge. Here it is here. So, as I said, that e-power truck, here it is within Solid Edge. The part we're going to be designing here is the clamp arm that goes between the clamp and the main structure of the e-power truck. Before I jump out of this view here and into the part design, I'd like to just talk you through a couple of things, because I'll use some terms as I'm doing my webinar, and I'd like to make sure you're all following along. So up here, very similar to Word and Excel, we've got what we call the ribbon. Well, this is where you'll find all your tools and a lot of your mostly used in design. This will change depending on the environment you're in. So whether you're in assembly drawings or 3D drawing, the ribbons change. You've got your main menu here. In here, particularly for new users, I would suggest that you will find tutorials and getting started features in here, and help and training. I found that very useful when I was learning Solid Edge about 8 months ago. And then here we have what is called the Pathfinder, very similar to history-based modeling. So you've got the parts and all of their assembled components, and this is where you'll see all your edits over time. The next thing to show you is the Quick View Cube. So this is a handy little feature that allows you to snap through different views and see them as we're going along. And then just this one here is a radial menu. So I've just held down my right-click button. This is where you'll find quick tools that the system, you can add things to this menu, but often the system puts the tools you use the most in this menu as it learns about the way you design. And then the other one I want to talk about just briefly is what we call the 3D steering wheel. So just move that along. This here is, so you've got a radial arm here and 3 different arrows. This is used for moving and manipulating components in the 3D environment. Cool. So just a brief overview of the interface, and we'll crack on in to make this part. So I'm going to go File, New, and it's going to be an isometric part. Okay, so similar to other CAD systems, well, it's not similar. What I'm going to talk about here is the base reference plane. So similar to 2D drawing, I should have said, you've got sheets of paper. So in this design here, we've got a webinar, this 2D drawing plane. What I'm going to be doing is adding in some circles and some drawings to this plane to kind of start the drawing off. So this little padlock here, just to point that out to you, it locks you into that plane for drawing. So we're going to draw the first circle, 50. So again, I'm using my radial memory menu to quickly find these tools. Tab also, as you can see, as I tab through, it jumps through to these different areas on the drawing. So I'm setting that to 25. Okay, and I'm going to be setting that to just a dimension there because I want to add a dimension after the fact using the Quick Dimension tool. So just to point that out again, that was the Quick Dimension tool, Smart Dimension, sorry, really a powerful little tool that Solid Edge uses. So what this has made some 3 regions. You've got the circle region and the square region. Now we're going to extrude that up into a 3D block. Now, this is currently in symmetry mode, so I'm going to turn that off. 34 high. And then, brilliant. Now, I could have set the dimension before to what I needed it to be, but I wanted to show you after the fact the 2D dimension sketches. So the sketch dimensions have been brought through to the 3D model, and they can manipulate the 3D model as well. So this is quite a powerful feature of the synchronous technology because it links the 2D dimension controls right through to your 3D model. So I'm going to be setting that now to 80 millimeters. I'm going to turn off those base reference planes because we no longer need those. And I can go through and delete those sketches as well because they're just going to add additional data that we don't need to use anymore. So I'm going to bring this out 50 degrees. So one of the things I want to talk about is design intent. So design intent is when Solid Edge looks at your design and tries to interpret what you may or may not have wanted to have designed into it. So what it's showing here is symmetry. So I know I do not want symmetry, so I'm going to be able to turn that off. But as we go along throughout the design process, you'll see the design intent box pop up, and it can be used and also be turned off on a case-by-case basis. So I'm going to bring that out at 50 mils. So I'm just going to move this design intent up to the top here and pin that to the top. So now we've got the base of the arm. So this here is going to be going around this pillar, and then there's an arm that's going to come up here, and I'm going to create a new pillar here. So this region here, this top of the arm here, we can now use that padlock again and create a new sketch plane. So I'm going to create a line across, and we've got a new region here. I'm going to bring that up. And this dimension box here, it's currently showing 76 millimeters. I can now enter the total dimension I need less the height of the current material, and that gives me an overall height of 150, less the dimension of 34. Cool, so we're starting to see some form come through. I'm just going to turn off the dimensions. Now we're going to add some rounding. So the rounding tool, which again was on my radial menu, is quite powerful. I'll show you 3 different ways to use it here, and the best ways to kind of maximize its use. So I'm going to set that to 40, all fillet. So this is going to find all the fillets inside the tool. And I'm going to set that to 2. And then you can also change this to all rounds. And so you no longer have to go searching through all of the different features. Solid Edge can find those for you and makes that change and edit really quick. The next thing to do is to add the pillar hole and slot. So again, similar to the other times, padlock comes up, we're going to lock on that face, create the hole, and then create the slot. And we're going to create another slot over here. Now I'm going to make these slightly different sizes because I want to show you 3D face relationships and how that can speed up your design. And because as we make edits later on, it's really important. So what we're going to do is we're going to select these regions. And then shift and slot, cut out the slot. Okay, so we've removed that material. So that's a little thing I did before, is I tapped shift. And shift alternates the extrude tool between symmetrical and non-symmetrical, which is quite useful when you're doing it on the fly. So under my ribbon here, I'm going to find face relate. So there's lots of different face relate tools here. The one I'm hoping to use is coplanar. So I want to face relate that face. Put my design intent up there to this face here. Actually, this face first and then this face. But you can see it's only moved one. So that design intent, because I turned off symmetry, it's not keeping this slot here symmetrical. So you turn it on, and now it's made it the same. Okay. Let me jump to the top here. Just going to quickly add some dimensions. So move this one. So under here, we're going to add some tolerances. So because this is clamping around that pillar, around the rod on the E-truck, it can be 0.25 millimeters bigger, but it can't be any smaller. Otherwise, we won't be able to put it over the pillar. And then add some more dimensions. So the first one from here to here. And then from here to here. So I'm just going to adjust this one. So these little arrows here on the dimension tool. So this is going to bring the circle closer to the wall. I'm trying to bring this slot. I'm going to shorten that to 34. And the same thing with this slot here. I'm going to set that to 25. My design intent box is covering it 25. Cool. And one more dimension to add is the front mouth of the slot. Okay. So again, that design intent, it's currently doing something I don't want it to do, which is adjust the thickness of the arm. So I'm going to turn off the offset. And so that's going to keep the thickness the same. But I want to bring this in closer because I want the material to be a bit thicker for the slots. And I know that the clamp it's going to be connecting to on the E-truck is 8 millimeters wide. So set that to 8 mils. Now we have another dimension there for that as well. Brilliant. So we're starting to see the form. It's rounded. We've got the slot through. Now we need to add in some holes for the clamp arm to bolt onto. So add a hole. Again, the good, useful padlocks come up again. Click 3 on the center there. Sometimes you can get a little bit lost with the cube, but I find it very helpful to use that cube to reorientate me quickly. So now I need to make a pattern of holes up this arm. Go up here, grab the pattern tool, rectangular. And you want that to a fixed width, and I want 7 holes and a fixed width of 20 millimeters. Brilliant. And I'm going to add in the dimension for the top, because I also haven't defined the thickness of the pillar. Again, using these arrows, set that to 45 millimeters. Okay, brilliant. Now, one of the things I do know is that this pillar needs to be raked back towards this to create strength, because this is a cast aluminium part. So any fatigue points, we want to kind of strengthen that as much as we can. So jump here. This edit here in a history-based system would be quite difficult to achieve. You would have had to kind of plan this from the beginning. But using the 3D steering wheel, I'm pivoting it from this lower hole. I'm going to adjust it 5 degrees. Now the system will let you know when you can't go that far, because you're going to start affecting the slot down in here. So I know I need to put that to 5 degrees. Keep all those holes in alignment and move those across. Now, something I did forget, but it's not too difficult in Solid Edge to update that retrospectively, was this hole. This hole size, I need to change that to be set for not just 10 millimeters, I need to set it for a general screw clearance of M10. And then we're going to set that to a close fitting. Okay. And so because those are all connected, it's now updated all of those, and they're now 10.5. Okay, hide the dimensions. The last thing we need to do is add a material. So material table. Solid Edge comes with a range of materials, but you can also import your own or create your own. For the presentation here, I'm going to be using cast aluminium, but cast materials on the outside look like this, but not on the inside. They would be shiny, so we're just going to make that consistent and add some silver. Because Solid Edge is a feature-based tool, it can find all the features that relate to the slots. So that's quickly painted those, but also these holes here would be painted. So you can select features on the model, but also as well as in the design tree. So we're going to select the hole in the pattern. So we now have completed the clamp arm. So I'll jump back to the presentation. So we've been able to show you some of these features talked about here: 3D dimension driven, 3D face relationships, design intent, procedural features. And then I'll show you the next thing to talk about is part drawing. So part drawing allows you to communicate your design to your subcontractors or manufacturers. One of the things that Solid Edge has is it's got the drawing tool inbuilt. So that allows you to retrieve dimensions from your 3D part and add further dimensions and annotations for manufacturing later on as well. So we'll jump back to Solid Edge. And we'll go save this part. So this may not be the save view that you normally see, but I'm currently using data management. So this here, I can automatically assign the part number based off a list of parts that my system maintains, and I can create a title for this, which is the clamp arm, and then I'm going to go validate. It's going to check so that part number is not being used, and the revision number is not being used. Check that, and I can save that. Brilliant. Okay, from this, I want to create a drawing from this model. This is going to be called the clamp. I'm going to use that template, sorry. So, because it's connected inside the same system, it's brought the model in straight away, and I'm just rolling the wheel back and forward to change the size. Create this view, and we're going to add a 3D view as well. We're going to bring the 3D view down here. quickly just make some changes here and show you the power of the 2D drawing tool. Don't want to maintain alignment, bring that over here. And then add a detail view. I'm going to zoom that one in. With this one here is to show the radius around that arm. The great thing also is that if you want to move, zoom in a bit further. If you want to move that circle, it's not snapping to it. There it is. I don't know. Come on. I know what it is. 2 seconds. I'm just going to delete that. What had happened, it's caught onto the feature of that radius, so it doesn't want to move. So I'm going to delete that view and put a new one in. So you've got to be really careful when you're putting the circle on. You don't want it to snap onto any of those features. And now when I move it, I can adjust that view after the fact. Scale that back up to 5. Okay, so we're showing the 2D drawing features, and that was pretty quick to bring the part in. Now I want to show you the power of what you can do bringing in some of the dimensions. So inside here we have retrieve dimensions. It's always this one here. So what you can see, it's brought in those dimensions that we had on the 3D model. I'm just going to rearrange them because it hasn't brought them in exactly how I like them. Cool, and then we're also going to add in the center mark for this hole. And then we're going to add the center marks down into these holes down here. So I just want to show you the center mark dimension axis. Normally it's based on the kind of X and Y, but because these center marks, they'll be aligned with this face here. I can align it with that axis and then select all those. Brilliant. Okay, as well as the center line. So we want to add a center line between here for the slot, for the pillar hole, and then through here as well. Cool. So the dimensions are out up here. So you can also see it's brought in those tolerances that were on the 3D drawing. And dimensions here. So we'll quickly just dimension this drawing. So now, because these holes are kind of all aligned, it's currently snapping it again to the horizontal axis. Holding down Shift aligns that to the shortest distance between them, between the 2 points, and then hovering over near this, it's going to maintain that distance between them. So whenever I move these dimensions, they're going to stay in the same position. Okay, I'll just continue to add some dimensions. So radius of 2. Now, I don't want to show a distance here. I want to show you an angle. So I've just pushed the A on the keyboard, and that brings out the angle. Okay, a couple more dimensions to be added. Slot depth here. Holding down Shift again aligns it to the shortest distance between. And we'll add the dimension for that too, radius too. Okay, now remember I talked about this hole here being an M10 size, or made for an M10 bolt. I'm going to call out those the feature of that hole using the feature call out. So I'm going to go here, feature call out, okay, and you can see that now that has brought through the details from the 3D drawing. So it's a 10.5 drill right through the part, and I'm just going to add in here that's all right, cool. So the last thing to add in is going to be a cutout on the 3D model here. So there's the broken out. We want to cut out this view, and I'm going to draw a circle using the curve tool. Curve tool. Escape. Close the broken out section drawing, and you can see this view here is asking me, I can either do it on this view or this view, and I want to go halfway through and display it on this drawing here. And we now have the cutout of the 3D drawing. Now, last thing I would just like to show you on the design drawing is the title box. So again, it's showing cast out aluminium, who the designer is, the date, the drawing number, revision, the title. All of that is being, again, brought through from the 3D drawing, 3D model. Okay, I'll save this one. Validate, no issues, save. Cool. So, now that we've created this new part, I guess we should bring it into the assembly, and just jump back to my presentation to summarize up the part drawing that I've done, jumping ahead there. So, just to summarize fast view creation, it's automated and creates production-ready dimensions. It's clear and accurate, and it's using ISO standards. Assembly drawing. So what we're going to do is we're going to bring that clamp arm in. We're going to put some nuts and bolts in there. I'm going to show you how to design in context, and then eliminate some interferences that the system can pick up. So back to my model. One thing I forgot to show you was in this view here, you can create set views. So currently I've got this showing all of the parts, but I know what I'm working on right now is only going to need to show the hydraulics and clamp. So we can hide all that. And you can also hide other components as required. So this one here, we're wanting to work with this clamp arm system here. Just watch closely. You'll see as I hover over, the little mouse symbol comes up, and you can see it's highlighting the right-hand mouse button. If I click right there, it's going to show me all the potential parts underneath there. There's only two in this one. Let me show you a more impressive one. There's a list of different parts. Now, I don't want to be selecting the motor, electric motor assembly. I want to be selecting the height and pivot assembly. Click that, and I want to edit in place. So now it's going to open up that assembly. Now, if I just hit Control Q, it's going to show all the parts in the background from my previous view. I don't need those at the moment. I can hide those. I want to import my new clamp arm and attach it to this part here. So the new clamp arm is 50017. 50017. So we'll bring that in. Okay. So this is currently using the assemble tool. So first things first is I'm going to align the bottom face with the top of this here, and then the axial, this guy. Now it's facing the wrong way, so I'm just going to rotate that around a bit, So, because often if you snap it too early, this arm here will be around the other side. We just want to snap that to that face there. And done. Press escape, and the part is now in place. So, again, there's always, with these kind of demos, there's always these little things I seem to forget conveniently. But it is to show you how Solid Edge can be used to enable you to do designs faster. You can see there's a slight gap here. I want to be able to quickly move this face here. Just going to change the way currently I'm selecting parts. I'm going to change the way I'm selecting, and I want to say face priority. So this little face here, I want to relate that to this face here. Now I could manually drag that up using the 3D stretch, but that's not going to be very accurate. What I want to do is use home. I want to say coplanar that face to that face. Done. So that now has increased the dimension to 37, and now that is going to be a tight fit, which is great. It's going to okay. If I go back to here, you can see it's probably better to show you on the drawing. So because I made a dimension change in the 3D environment, and we're using the same tool, any change in the 3D environment is reflected in the 2D environment, or it makes you aware of those changes. So I'm just going to quickly go in here and update views. And it's telling me here, so there was a dimension change from 34 to 37. So I want to view those. So there it is there. And I want to clear all. So I'm happy with that dimension change, and these drawings have all been updated. Okay, so that's now assembled. The part is in place. While we're in this drawing, I want to show you how to create a part also in the 3D environment without having to import like we did with the clamp arm. So we're going to create a part in place. It's going to be on this dimension here. Just need to align this little guy here. No, I want him to be aligned this way because I want him to be lined up with the parallel bits of the tongue. F3, and then I want to be at the center. Hold on. This one. Let me just try that. I think I locked him onto the wrong face. F3. And then that one. Cool. And it's going to be made out of general purpose silicon, and create part in place, origin, done. So it's asked me for a new part, so I'm going to go assign all, and this is going to be silicon cap. Validate, save. So I want to be showing those parts in the background because I'm designing a cap to cover this rivet and washer. Create a cylinder. I'm going to be creating it on that plane there. F3 from the center, bringing it out 34. Now we don't want to be going into the model, so add shift again, coming up 10. Add some rounding, and it's going to be 10. Oh, not 10, sorry, 5. And currently this is a solid model, so we need to cut out that rivet and the washer from the bottom. So we want to go home, subtract. So we want to subtract from this part. We want to subtract the rivet and the washer. Done. Control Q, and now you've created a snap washer that'll fit over that rivet and washer right first time. Jump back out into the view, and we'll close that. Now I have a cap over that clamp arm, and we'll go close this view as well. So, as I zoom in, you can see that the arm, sorry about the snapping zooms, the arm isn't in place, so we need to assemble that. We're going to assemble, okay, this one to that hole, and then that hole to that hole. Oh, no, that didn't work. Let's go Control Z. Assemble this radius to that one. No, I haven't forwarded. Oh, my one. I'll get there. Assemble. I was assembling instead of the axial, I was selecting the circle, and I want the axial align, and then wrong one again. My bad, sorry guys. This one down here. And then that axial to that axial. Brilliant. Okay. So now that is in place, we need to add in the fastener systems. So Solid Edge has inbuilt a fastener system that uses standard parts that you can buy off the shelf. So I'm going to put a fastener system in. I want it to be in this hole. Actually, no. So that's going to try and put a screw in a bolt in every hole. We only want that in single. Exit. We want this one and this one, and then right click, and we want it to come right through both. So what that's going to do is Solid Edge is going to now look at the available parts and see what the most appropriate bolt is to go into that position. So the bolts, we're going to use M10 grade C, and for the top stack, we're going to use a washer, plain grade C on the top and the bottom. Bottom stack. And then we're going to use a non-metallic insert, so a Loctite bolt on the bottom. And then we're going to save this as the fastener system for webinar. And then OK. So we've created 2 bolts. And that doesn't seem so safe. I should probably shorten the length of that bolt. I'm going to open up that open up the fastener system. Hold on. Change that. So the maximum extension is 5 millimeters. We're going to set that to 2. And that's going to reduce that, make it a bit safer. Now we've got some bolts in there, which is brilliant. Okay. So clamp arm is on, it's attached. It's got a dust cover, bolted through. And you can see out the back here, we're missing a caster conveniently. So I'm going to show you how to replicate a caster again in place of the design and speed up your design process. So hover over. Actually, I should finish doing the fastener system. Hover over here, right click, and I would like to get this assembly here. Nope, that's just the arm. I don't want that one. I would just like the casters. So edit definition. No, sorry, my bad. It's meant to be edit in place. I'd like to go back to its original file. Sometimes the little mouse clicks, you can click a mouse and it takes you to a place you definitely don't need to be. like I just did. Okay, so we'll go to the top view. We're going to be copying this caster, nuts and all. I'm going to move my 3D wheel into the center of this washer. And then, like your other Windows applications, holding down Control is going to copy that part. System does a little bit of thinking and bring that down here. Done. So this warning here is saying, hold on, I thought you wanted the caster to be back where it was. Now I know I don't need it to be, so I need to suppress some of those relationships. So I don't need to suppress them, I'm going to delete some of those relationships. And now we're back in alignment. Okay, so 2 casters. Last thing to show you about this caster drawing, adding some dust cover caps to these nuts. So there's already a part in the library. Master mover, work in progress, and that part number is 236, dust cap. So we want to hold on, where did it disappeared to? Let me just double click that in. I'll get rid of the other one, didn't do what I wanted to do, so I need to align it there, and then I'm going to align it with the face of that. There you are. That one's gone. So now this feature here, when I first saw it, was quite powerful. I'm going to replicate this dust cap to cover all of these screws really, really quickly, and show you how, using this feature-based system, you can leverage the features. So I need to go home, under pattern, I'm going to duplicate a component. I need to duplicate this component, and I want to duplicate it around this nut here. And then right click. So it's found all of the other nuts in the model. And then we want to say OK. Now all of the bolts have covers. So I think that was a pretty cool feature, particularly useful when your pattern is not in a consistent arrangement. It could be a radial, it could be a range of bolts over a chassis or a panel. It finds all those bolts very quickly. Finish that, close that. So now we've got an assembly that's starting to take shape. We've got 2 wheels. We've got some dust covers over those bolts. The last thing we need to show you is how to check for interference in your model and to make changes on the fly. So using that, again, quick pick. We want the clamp arm here. We want to get it in place. So if you can, sometimes finding a tool inside here can be very difficult. Like there's hundreds of tools, hundreds of different features you can use. So one of the things, if you're thinking of something and going, what am I trying to achieve? This find a command box down here I found very helpful. And what we're looking for is interference. Probably spelled interference wrong, so I have to get rid of that. Oh no, there it is. It's telling me interference is under inspect. Check interference. Cool. So I want to check the interference between this part. Actually, hold on, I'm jumping ahead. I want to check the interference between this part and this part when when these springs are fully extended. So I'll just go close and return. Get it in place. this component out. You see those springs will update. Hold on. Reset. I used the wrong thing there, drag didn't keep it on the line. I want to move the component. Actually, my apologies. I feel like I've made the step already. So this is a bit funny. Essentially, in the assembly here, this face here was interfering with this. And I'll just reset that quickly to show you how that we can do that. I'm going to return that up 5 mils, so 10 mils. This is where it was before I adjusted it when in my practicing for this webinar. And we want to then drag the component out. And clearly you can see there's going to be some interference. This is going to be quite obtuse, but I would like to show you how to use the interference tool. Check interference between this part and all other parts in assembly. Okay. Hold on. So it's showing you there, highlighting the interference. So sorry that took a little while to get to, but you can see that it's showing the interference between these two parts. Now we want to fix that. So we're going to reverse the change that I did. It is in place. We're going to drag that component back out of the way. We're going to do the side view. I'm going to return those radiuses that I moved into the way for the demonstration back out of the way. Face priority. Move those back down 10 mils. All right, so that, guys, concludes the webinar on part design, part drawing, and assembly drawing. The next webinar that I'm looking at doing will be on assembly drawings, which will take this clamp arm here and add that to a, so need to just go back to hydraulics and casters. It'll show the, I've just hidden my original part here, sorry. Show how to make an assembly drawing in this view and how to quickly create manufacturing drawings for that part. So I'll just jump back to my presentation. So as I said, I showed you in the assembly drawing, it's automated fastener library. Assembly and fit and function is very useful and quick. And there's also a rapid top-down design approach for when making that dust cut, as well as making the changes to the casters. So I'm just going to quickly now jump to the questions and see if there's any questions. It appears that no one's had any questions, which is great. So if you have any questions, remember to send me an email. I'll be posting the webinar on our YouTube and making it available to people to, again, rewatch to find out any of those tips and tricks I've talked about. If you have any other questions regarding the product, feel free to contact me. And we're looking at doing a series of webinars for 2020, Solid Edge 2020, which is launching mid-June. And Paul Abbott and I from Siemens will be presenting the features of that tool and the new things that we're seeing coming out for CAD engineers for 2020. Great question about the standard parts. I can show you that is found in GTAC. So if you have access to GTAC, you should be able to use your Solid Edge logon. Download the Solid Edge DVD. I'll quickly jump to my desktop and show you. So when you download the Solid Edge DVD, you'll get an install file, and inside that, you can install the standard parts library. Now, I've had 1 or 2 questions, I believe, from James Mack. He was looking for some standard parts of a very large dimension, some tubes and stuff, because they're doing some rather large structures. The standard parts tries to cover 80% of our customers and the needs they have, but it does have some limitations because some of the technology that people are making out there is at the far ends of what Solid Edge standard parts library covers, but it will get 80% of the parts you have, and you'll be able to speed up your design process using that instead of having to make your own bolts. Does that answer your question, Matt? So under GTAC, download the DVD, and on that install, you'll see the standard parts library installation. Not a worry. Any other questions from the team? Brilliant. Well, thank you everyone for attending. Hope it was helpful. Sorry that there was a couple of little jumps in there. It was my first time doing a webinar. We're hoping to do more of these, and hopefully I'll get slicker as we go along. And I look forward to coming out and visiting you guys and doing the work, seeing the work that you're doing. I always enjoy hearing the different things people are working on and seeing if we can enable you using Solid Edge to make those designs and bring them to market. Thank you very much.